So again, when I see this big thing that says Extrema and I see all these bolded letters, this is stuff that I like to write down into a notebook to keep notes on it. So my recommendation to you is the same. So I don't know if I necessarily need to read this to you, but I will just to make sure that you know it's important. But if you don't care about it and read it yourself, then just skip this part of the video. But extrema, points on a graph that are high points or low points are called extreme points or extrema. A local maximum or minimum of a function is the largest or smallest value of the function within a small interval around an extreme point. Meaning if I have some sort of graph like this, then if I were to just focus on a small section between here and here, this is a local maximum because it's looking at that section. Now, a global maximum or minimum of a function is the largest or smallest value of the function over the entire domain, meaning if I was looking at the whole thing from negative infinity to positive infinity at this graph, the global maximum is the highest point over the whole thing. So there can be many local maximums or minimums, but there's only usually one global maximum if we look at the y values or minimum. So the plural of maximum is maxima and the plural of minimum is minima. So for the actual question, look back at the graph in problem 2-1 representing Riley's drive. Let's go ahead and I'm going to paste this here. So it says, look back at the graph, which points are the maxima? So that's all of them, and I'm going to do that in light green here. Label each maximum point as a local or global. What is happening in Riley's drive at these points? So here is a maximum, and here is a maximum. And basically when I look at these here, I see this is my global maximum, and this one here is a local maximum, because this is the highest point in the whole function, and if I look at a small section, then there's the local one. What's happening at the drive? It's basically what's happening is Riley is changing from going away from the house to going back towards it. So let's say like turning around might be a thing. For B, it says which are the minima, so lowest points here. So I'm actually going to call it these points right here. And so when I'm going through the minima, the lowest points here, the global are the lowest, right? So even though I have two, the minimum value is really just 0. That's at home, versus this is the local minimum right here. So I got global here. I'm not going to be too picky if you consider it 2 or 1 global minimums or minima or not. But when I'm looking at this, what's happening at the local is that, again, changing from getting closer to the house to getting farther away from the house. So turning away from the house versus like actually being at home or landing at that spot. Describe the graph near a local maxima point using the words increasing and decreasing. How is it changing? So for the maximum, we are going from increasing and it changes to decreasing. Where we're looking at minima, which is D here, it's the opposite. So if we're looking at the minima, we're going from decreasing to increasing afterwards.